guys, let's get started. This is 8th grade math, Unit 3, Lesson 4, comparing proportional relationships. So previously, we've always had one proportional relationship that we graphed, and we used it to answer some questions. But what if you have two proportional relationships? That's what we're going to discover later on in this unit. For this lesson, you must take notes. Note-taking is extremely important to learn any subject. Unit 8.3.4 Lesson Notes. You must take good notes and turn them in with your assignment. Handwritten notes are essential. Okay, problem 1a says, the equation y equals 4.2x could represent a variety of different situations. Write a description of a situation represented by this equation. Decide what quantities x and y represent in your situation. Okay, so let's write that equation down in our notes. This is problem 1. Write that down. And they gave us an equation. Y equals 4.2 times x. And they're asking us, what is an example of a situation that could be represented by this equation? It means there's 4.2 times more of x than there is of y. Well, this could be a graph of distance and time. What if time is down here on the x-axis? Maybe time in, minutes? And on the y-axis, what if this is, maybe feet? I guess. Okay, feet. I'm just going to try to imagine a situation. So the y-axis is going to be distance, and the unit is feet, and the x-axis is going to be time, and the unit is minutes. So that means something moves 4.2 feet per minute. Okay, I'm just making up this situation. I just am imagining what it could be. This is 4.2 feet per minute. That's what that constant of proportionality means. 4.2 feet per minute, according to this imaginary situation I've said. So what moves 4.2 feet per minute? I don't know. How about a snail? Or a worm? What else? How about ketchup dripping down the counter? How about honey moving down a plane? That's kind of a ridiculous situation. Let's go ahead and say this is the speed of some snail. Okay, here's Mr. Snail, and he's got a snail trail here. He moves at a speed of 4.2 feet per hour. Very slow. You know what? Is it a snail? Maybe I should say a slug, right? Oh, not hour, I mean minutes. Oh, wait a second. You know what? 4.2 feet per minute? Maybe that's too fast for him. I need to think about this again. That's actually too fast for a snail or a slug, right? I was thinking per hour, but I wrote down minutes. Okay, not him. What moves 4.2 feet per minute? I guess it could be a worm that wiggles quickly? A turtle! I got it! A turtle! That's about a turtle's speed, isn't it? Okay, would you like me to draw that picture? Here's his head. Here's his front foot. Here's his back foot. He's got a tail. He's got a little bit of a body. Okay, here's Mr. Turtle. He's a tortoise or whatever. I'm no biologist. I'm not sure. He moves at 4.2 feet per minute. So that's my situation. Write a description of a situation represented by this equation. Okay, let's go back to the GeoGebra page. So in your notes, please make sure you have the equation and that you have the constant of proportionality and what it means. So you'll need to put units. Mine is feet per minute. And then I drew my graph just to help me visualize it. It means for every minute, this turtle's going to go 4.2 feet. And for 2 minutes, it's going to go, something like that. And there's a picture of my character. Okay, let's do the work. Write a description of a situation represented by this equation and decide what quantities x and y represent in your situation. Okay, my answer is my answer. Your answer is your answer. So don't copy my answer. This is my answer. I'm even going to write that here. Cindy's answer. You must think of something different, okay? So I'm going to say, my tortoise runs at a constant speed of 4.2 feet per minute. It is represented by the proportional equation y equals 4.2x, where y is the distance in feet and x is the time in minutes. There, okay? This is for me. Don't copy my answer. You need to think of your own answer. Is it hard for you to think of something? This is just one example here. Let's call that example 1 in your notes. Now you need to think of example 2. What could it be? There's going to be 4.2 something per one of the other things. How about, I don't know, is there any recipe that uses, say, this is just an idea. How about a recipe that uses 4.2 tomatoes for every something else? Oh, I have an idea. Oh my gosh, I'm really good at this. 4.2 tomatoes for every piece of garlic. Because, garlic is very spicy. Very, very strong flavor. So a tomato sauce. Maybe this is a spaghetti sauce. And it uses 4.2 tomatoes for every one garlic. No. One piece of garlic. That little piece. If you break it apart, you get pieces of garlic. So then the equation for spaghetti sauce recipe is y equals 4.2 times x, y equals tomatoes, and x equals pieces of garlic. Okay, how about that equation? It means if you have one piece of garlic here, let me make a little table, and x is garlic. Remember, don't forget that x is garlic. If you have one piece of garlic, you're going to need 4.2 tomatoes because garlic is so spicy. And if you have two pieces of those little pieces of garlic, you're going to need 8.4 tomatoes because garlic is so spicy. And if you have 10 pieces of garlic, because you're making a very large batch of tomato sauce, then you'll need 42 tomatoes. This is just an idea. I don't cook. Okay, so I have given you 2 ideas. Now it's your turn. You can think of an idea. It could be a speed or a recipe or whatever you want. Oh, I have one more idea. Oh my gosh, I'm really good at this. Here's another example. This is just another idea. How about somebody has a job and they teach classes for 15 minutes each. No, 10 minutes each. I'm trying to, yeah. Okay. My friend teaches English online to students in Asia. And each class is a 10-minute class, okay? So one class is 2 minutes. This is just an idea. One class is 10 minutes, and for each class, she earns $4.20. So she just teaches 10-minute classes over and over and over again. So the money that she earns, this is just an idea. I'm thinking of ideas. The money that she earns, earn money? I think I should have just said money. Anyway, the money that she earns is $4.20 times the number of classes. So now you can see Y equals money. The constant of proportionality is the rate that she gets paid. And X, the value of X is the number of classes. That means if she teaches one class, hold on, let me just make a little table here. Always make a table to help you understand your data. If she teaches one class, my friend gets $4.20. But she never teaches just one class. If she teaches 10 classes in a row, she gets $42. If she teaches 100 classes, she gets $420. So she works all day long. Okay, that's another idea. So here are 3 examples to help you. The first example is a speed, feet per minute. The second example is a recipe, and I'm comparing 2 ingredients, in this case, tomatoes to pieces of garlic. And the third example is a job where you earn money, and this is your rate of pay. My friend gets paid $4.20 per 10-minute class. Okay, those examples can help you. Now you try to make your own example. After you make your example, then make a table to represent the situation. Okay, in my turtle situation, remember my turtle moves at a rate of 4.2 feet per minute. I want to write this with units, but my pen tablet's really slow. Okay, and that's times X. So here's my equation, which is not different than their equation. Anyway, we're all using the same equation. So if X is 1 minute, my turtle has moved 4.2 feet. And at time equal to 2 minutes, my turtle has moved 8.4 feet. Well, I got tired of watching, so I went away and I came back, and after 10 minutes, my turtle has moved 42 feet. Wow, go turtle, go. And I came back one more time. I went away and then I came back 15 minutes later. So how far has my turtle moved? Let's calculate that. Y equals 4.2 times 15 minutes later. So 4.2 times 15 is, hey, I'm no genius. Let me just, wait a second. I can do this in my head. If 10 times 4.2 is 42, then 15 times 4.2 is half as much more, because 15 is half as much more than 10. Half of 42 is 21. 42 plus 21, that's 63. Hey, I am a genius. I don't need a calculator. I can do that one in my head. Ding, 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 ding. Okay, this is my example. You need your own example. You do. You need your own example, and I want to see your example not only on your GeoGebra screen, but I want to see it in your notes. Okay? So your notes are going to say 8.3.4 lesson, and you're going to have an example of like my turtle, but it's going to be yours. And then go ahead and write out a table in your notes. Show me your information, because you have to do this anyway before you put it into your graph. So explain the situation, sketch what your graph is going to look like, draw the table. I want to see these 3 things filled out in your notes because you need to sketch this anyway in order to do the work. Otherwise, I don't know if you really did the work. What is your constant of proportionality? 4.2? Don't just say 4.2. You have to explain what that is. For my turtle, it's feet per minute. For this recipe, it's tomatoes per garlic pieces. And for my friend's job, it is dollars per 10-minute class. Okay, now they want us to graph it, and in your notes, you sketched the graph. But here in your GeoGebra page, you need to do a much better job. You're going to use the text tool, and you're going to put a lot of information. First, I want to see a title on your graph. We haven't done that before, have we? First, I want to see a title on your graph. Next, I want to see labeled axes. So I'll just put on here label axes, both axes, X and Y. The third thing I want to see is your units must be specified. Put the units in parentheses. Let me show you what I mean. When you label this axis as time, then put the units in parentheses. Time. In my situation, it's time in minutes. Your situation can be different. And this axis is distance. And what is the units for my turtle? Feet. I don't really know how fast turtles are, by the way. Looks like I forgot my E. Never trust my spelling. Okay, guys? Never trust my spelling. Okay, I want to see your title. I want to see your axes labeled like this. Label here, distance. Label here, time. I want to see your units. The units are feet and minute. Then you must have your scale. Do you remember what scale is? Oh, I can't even remember how to spell it. Every time I talk and write, I'm full of mistakes. Okay, you must have the scale on your graph. For my turtle situation, I measured his distance over a span of 15 minutes. Remember, my X is minutes for my graph, and my Y is feet. So I went from 0 to 15 minutes. That means I need tick marks here showing from 0 to 15 minutes. Maybe I'll count by 3s. That looks like it's going to be too small. And I won't be able to see it clearly. Look, I'd get 15 minutes in right there. That's too small, and I wouldn't be able to see it clearly. So I'm not going to have a scale of counting by 3s. I want 15 minutes to take up a lot of space so that it's easy to read my graph. So how about we do this? Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, look, 15 goes right here. So I can just use 1 tick mark for every minute. This is going to be easier than I thought. So when I scale my graph, 1 tick mark is 1 minute. You need to use the GeoGebra text tool like this. And you need to make it look nice and neat and clean. Okay? Count your tick marks and do it properly. If you need to move them again, go to the Move tool here, Move, and then click on your number and just tap your arrow keys in order to move it into position precisely. You can move it by small increments using your arrow keys. Now I want to go quickly and give you more time to do this assignment. But remember, my scale is going up to 15. What is your scale going up to? It depends on your data points. My turtle goes a maximum distance of 63 feet. That means up here needs to go up to 63 or something like that. Well, what can I do to get my scale up to 63? How about if I do counting by fives? 5, let's just try 10, 15, 20, 25, 30, 35, 40, 45, 50. Let me mark that before I lose count. 55, 60. Oh my gosh, looks like I did a pretty good job. 60 there. So this is going to be 65. That means when my turtle, after 15 minutes of walking, I'll just go up here to about 63. I guess that's about right here. There. After 15 minutes of walking, my turtle went 63 feet. So that scale works good. Now you are using the same linear equation. So if you have a range like this, then your scale might be the same as mine. But if you use x values of like 100, then your y value is going to be 420. So you're going to need to go up to 420 on your scale. Please think about scale and make it appropriately. Okay, next question. Who makes... Oh, I'm sorry. This is problem number 2. Okay, let me stop this video and start a new one.